Okay, good morning, ladies and gentlemen. We're looking at the 1E notes here. Um, Parallel lines, similar triangles, and we're going to do this video right now, and you can sort of take your notes on this little triangle that I made right here, okay? And I'm going to go into GeoGebra and make the same triangle because I want to sort of see something with the angles here, okay? So if we go into GeoGebra, we're going to make our triangle ABC, kind of look like that, okay? Now we're going to make a line that goes through the triangle that's parallel to AC. Okay, and we're going to see something that sort of happens here with the angles and how we make some new triangles here. Okay, so we're going to take the point button. We're going to click a point over here. That's going to make our point D. Okay, again, follow along, pause, go back if you need to. Make sure we're following along. Okay. So we're going to do a parallel line. Now, for parallel line, it's going to ask you, I know you can't see down here, but select a point and then a parallel line. So I'm going to hit point D. So it goes through point D. And I'm going to hit AC, which is the line it's going to be parallel to. Okay. And so here we got a new line right there that's parallel to AC that goes through the triangle at point D. I'm also going to take this point thing here and put a point E right there where these two lines meet, BC and DE. Okay. And now you'll sort of see if we move any of these points as AC sort of changes its slope, DE changes its slope the same way. Okay. So that's kind of the cool function of that parallel line thing there. Okay. Now I want to look at angles. I want to look at angle here, this angle BDE, and I want to also look at angle DAC. Okay. Because when we have lines that are parallel and they have like the same other line that goes through, that's called a transversal when I have these angles, the angles we're going to see something here. So we're going to measure the angle. So we're going to hit the angle button here. We're going to hit angle BDE, which should give us a 43, which is 43.8 degree angle there. And I'm going to do the same thing here with angle DAC. And as you see, these two angles are congruent to each other. They're equivalent, okay? And that's because these two lines are parallel to each other, okay? And the same thing is going to happen over here. So when we go over here and we measure this angle BED, and it just so happens that angle's 43 I don't want to do that. Let's move that a little bit. So let's say we have that angle there, 42.4. This angle here is going to be equivalent to this angle down here. Wanted to change the numbers up so we didn't get confused. So we have 42.4 down there as well. And as you see, as we move point C, okay, these two angles here are going to be equivalent. These two angles over here are always going to be equivalent as well, as long as this line here is parallel to this side right here. Okay, if they're not parallel, then they're not going to be the same. Okay. So let's say I just sort of move it around like this and I get 41.5 over here and 39.2 for both of those. I can also get my third angle, angle B. So hit the angle DBE. That angle will be 99.3 degrees. Okay. So angles of a triangle added 180, which these three numbers do. But again, now we have two triangles. Okay. I'm going to go over to paint here and sort of show you all this. We got two triangles now. And so we have this triangle BDE, which let's see if we can snip it. Okay. Copy it over to paint. We also have this whole big triangle BAC. So I'm going to snip that over to paint so we can mess around with it a little bit. Okay. So we got that. Bring it over here to paint. Okay. Now what we should see is that this little triangle BDE is going to be similar to this big triangle BAC, okay? So this triangle BAC is similar to that, okay? So what's going to happen now is the triangles are going to be similar to each other. We can sort of prove that because all the three angles here, the three angles in BDE, 41.5, 99.3, and 39.2, match up with the three angles in this bad boy, 41.5, 99.3, 39.2. All right. So now let's just throw some numbers on some of these sides here. Okay. So let's say this side is 7, this side is 8, and this side down there is 12. Okay. So let's just say hypothetically that this thing has a length of 10.5. Okay, so it's 10.5 all the way from there to there. All right. And so let's say we got to find out what BC is. All right. So we don't know what BC is. So that could be our X. Well, we can set up a proportion. Okay. We can set up a proportion. All right. And we could also set up a proportion for AC down here, which is Y. We know this thing's 12. All right. So look what corresponds here. The 7 in this little triangle right here corresponds with 10.5. So we can do 7 over 10.5. And we can do an equivalent proportion with 8 and X if we want to. And, you know, how do we solve proportions, ladies and gentlemen? Well, we cross multiply. Okay, we cross multiply and divide it out. Okay, so if we have 10.5 times 8, okay, 10.5 times 8, and let's see what that is. I don't really know off the top of my head. Is 84. 7 times X, 7X, okay? And then we could solve for what our X value is by dividing by 7, and 84 divided by 7 gives us 12, okay? So the whole length of this BC thing right here that we could get is 12. Again, the triangles are similar, so the sides that are corresponding to each other, basically the sides that are sort of in the same location, are going to be equally proportional, okay? So this thing has a length of 8, and this whole thing BC has a length of 12. All right. We could also do the same proportion with the 12 and the Y. Okay. So the 12 and the Y, okay, are going to have the same proportion as the 7 to the 10.5. So we can do 7 over 10.5 equals 12 over Y. Okay. So if we do 10.5 times 12, which is 126, and that's equal to 7Y. So we'll do 126 divided by 7, and we get Y equals 18. Okay. So we have similar triangles here, kind of like what we did in the previous thing, where the sides are going to be equally proportional to each other. And this kind of proves it, okay? And so whenever the triangles are similar, we know they're similar by angle. So we know the sides are going to be equally proportional to each other, okay? Basically what happens here is that if we were to divide the bigger by the smaller, so let's say, for instance, well, heck, if we did 7 divided by 10.5, or if we did 8 divided by 12, or if we did 12 divided by 18, I need a bigger eraser here. All right. Basically what would happen is this 7 right here is 2/3 of that 10.5. Okay. And the 8 is 2/3 of that 12. Okay. And that 12 is 2/3 of that 18. Okay. It's going to be the same proportion. It's dilated by the same amount. So basically, You know, if we have a bigger one and we're dilating it down, okay, we're dilating it by a scale factor of 2/3. Okay. Now I want to talk about one more thing here, and I'm going to clear my thing again. Stop and make the notes that you need to make. Hopefully, this is pretty much a review. And one more thing I want to talk about to sort of clear this up, because we can do some shortcuts with these things as well. Copy this again. What we have here, ladies and gentlemen, is let's see what we had here. So we had 7, and this whole side was 10.5. All right. And over here we had 8, and this whole thing was 12. And here we had 12, and that whole thing was 18. Okay. Now we could also do some proportions along the sides of the triangle, basically the two sides where that parallel line cuts it. Okay. So this parallel line cuts this triangle. We can do some other proportions here, and I'm going to show you guys what I mean here. So this whole thing is 10.5 from A to D, or A to B, excuse me. If we do 10.5 minus this 7, that little piece down there is 3.5. Okay. And now if we come over here on the right-hand side, this whole thing is 12. This bigger part is 8. So we subtract those, and that's 4. Okay. We can set up proportions that are going to be equal along those sides as well, because we see if we do 7 over 3.5 and 8 over 4, if we do 7 over 3.5 in a calculator, it's equal to 2, and 8 divided by 4 in a calculator is also equal to 2. Okay, so we can set those things up accordingly along those sides, and also be able to get some proportions from that without having to use the similar triangles. Okay, so those are the notes that we have there. Make sure you copy those down and copy down what you can, and continue these notes. Do the problems that I assigned for homework, and then we'll do the rest in class next time around. Thank you.